Okay, let's find the first partial derivatives of this function. It's a little bit more complicated function involving x and y. So let's write here partial derivative of z with respect to x. Taking the derivative of this function will involve product rule. That's where we leave part of the expression intact while multiplying by the derivative of the other part. Then we do the original of that second part times the derivative of the first part. And this is because we have two expressions being multiplied by each other, and we just want to differentiate them separately here. So let's see if we can do this. So e to the xy stays itself. The derivative of ln x with respect to x would be 1 over x. Ln x gets to stay. And then the derivative of e to the xy, okay, that's going to be itself, but notice this. That's a chain rule. Whenever you have e to a constant times the variable, y is treated as a constant here, you have to use chain rule, which means you multiply by the derivative of the xy, which would be y. And that's our answer. We don't really have to simplify it any farther if we don't want to. Let's try it now with respect to y. Original function was z equals e to the xy ln x. All right, we'll set up product rule once again. Great. So leave this part alone. Here, the x is treated as a number, and the derivative of ln of a number would just be 0. So that's what we're going to put. It's because we're differentiating with respect to y, not x. Let's see, ln x stays. And let's do e to the xy times the derivative of the exponent. This time the variable is the y though, and the x is treated as the constant. So we would multiply by x here. And there's our answer.